Today I want to take a look back at an earthquake that, in my opinion, doesn't get cited nearly enough in the scientific literature or in public discussions about Jamaica's earthquake history. When most sources talk about earthquakes in Jamaica, you usually hear about two major events. The 1692 Jamaica earthquake, which devastated Port Royal, where roughly two-thirds of the town was documented to have been swallowed up by the sea, and the 1907 Kingston earthquake, which struck Kingston and triggered major fires that resulted in significant loss of life. Now, I completely understand why these events dominated the conversation. They were both incredibly destructive. In each case, hundreds of people lost their lives and there was widespread damage. But that said, there are other earthquakes that deserve a closer look. One such event is the 1993 earthquake, which affected Kingston and St. Andrew. Today, we're going to revisit that event by looking at the geology and geotechnical aspects of the earthquake, based on a paper written by the late Rafi Ahmad, published in the Journal of the Geological Society of Jamaica. So stay tuned. Now, I have a personal childhood connection to this earthquake, which I shared briefly in my Seismic Shorts video series. At the time, I was just about to start basic school, and for my non-Jamaican viewers, that's what many other parts of the world would call preschool or kindergarten. This was the first time in my life that I had ever experienced or even really known about something called an earthquake. I was at my aunt's house in Kingston with my mother. I remember being in the bathroom when I suddenly heard this rumbling sound and felt the entire place shaking violently. Of course, I was scared and confused, and I did what any toddler would do. I ran straight to my mother. Life is interesting sometimes. Here I am, some 33 years later, talking about the same experience, not just the memory of it, but also the science behind it and the wider implications of the event. Something that at the time I obviously had no clue about. That's so interesting. But anyway, let's move on to the next segment. Now, the earthquake struck on Wednesday, January 13, 1993 at 12:11 p.m. local time. It had a magnitude of 5.4 and occurred in the mountains of eastern Jamaica. In his paper, Rafi Ahmad reported that the epicenter was located at 18.12 degrees north latitude and 76.69 degrees west longitude, which he documented as being about 15 kilometers northeast of the Halfway Tree area. Out of curiosity, I took those coordinates and plugged them into Google Maps. Of course, Ahmad was referring to the straight line distance, but if you were to actually travel to that location, it would be a roughly 2-hour drive covering about 47 kilometers depending on the route. In terms of impacts, 518 families were reported to have been affected, mostly in Kingston and St. Andrew. 2 deaths were reported as a result of the earthquake. 1 person drowned after a cliff collapsed in Portland, and another person died from a heart attack brought on by the shock of the event. The effects of the earthquake were mapped across an area of about 225 square kilometers. And Ahmad's study specifically examined geologically controlled earthquake-induced processes in 3 main areas. First, the southern portion of the Port Royal Mountains and the limestone hills within the Wagwater Belt located south of the epicenter in St. Andrew. Second, The Ligani Plain, the large gravel fan on which the city of Kingston is built. And third, an area about 2 kilometers offshore near 7 Miles Bull Bay in the western section of Kingston Harbour. Now, the paper also had a section dedicated to the geology of Kingston and St. Andrew. Before we can really understand the damage caused by any seismic event, it's important to understand the geology through which those seismic waves propagate. So here I'll give a summary of how Rafi Ahmad described the geology of the area affected by the earthquake. So to begin with, the city of Kingston is located on the gravel fan of the Ligani Plain, right at the base of a faulted mountain front. The gravel fan is bordered by a ring of low hills made up of limestone, which Ahmad referred to as tertiary limestone, including Long Mountain, Dallas Mountain, and Stony Hill. A quick note here, the term tertiary was standard when Ahmad wrote his paper, but in more modern geological literature, these types of rocks are typically referred to as Paleogene limestones, reflecting updates to the geological timescale. Anyway, overlooking these hills are the Port Royal Mountains, composed of Cretaceous to Paleogene rocks associated with the Wagwater Belt. In terms of the broader tectonic setting, Jamaica sits within a seismically active left lateral strike slip fault zone, which is the boundary between the North American plate and the Caribbean plate. Looking more closely at the Port Royal Mountains and the Wagwater Belt, the rock strata here consist of an approximately 7-kilometer thick sequence of highly faulted rocks. These include conglomerates, sandstones, and shales, primarily from the Wagwater Formation and the Richmond Formation, along with andesitic volcanic rocks of the Newcastle Volcanics. At the base of this sequence, Cretaceous granodiorites and andesite or andesitic rocks are exposed, and the western margin of the belt is defined by the Wagwater Fault, which is a northwest striking fault that plays a key role in the structural geology of the region. Now turning to the limestone and the gravel fan of the Ligani Formation, the limestones exposed in this area are extremely variable. They occur as well-bedded micrites, recrystallized limestone, dolomitized units, chalky deposits, bioclastic limestone marls, and brecciated limestones. Major faults are also present within these limestone units. The Ligani Plain itself is an ancient gravel fan formed by sediments deposited by the Hope River before the river shifted to its present course. Today, the fan surface slopes gently southwards toward Kingston Harbour, and the youngest coastal feature in the area is the Palisadoes, which is a tombolo built up through longshore drift of coarse sediments from several rivers, including the Hope, Cane River, Yalas River, and Morant River. So the main earthquake-induced processes reported in the study were ground shaking and ground failure. The shaking lasted between 10 and 14 seconds and involved strong horizontal and vertical motions. And these motions were strong enough that heavy objects shifted laterally and in some cases were even thrown upward. For example, an overhead water tank at Jamaica College in Ligani reportedly moved from its base. Residents in Greenwich Town also reported that a 400-gallon water tank shifted eastward and a television set fell from a table. Ahmad also reported that domestic water supply was disrupted in parts of Kingston and St. Andrew due to a broken water main. Moving on to ground failure, one of the more common observations involve cracks, fissures, and localized liquefaction. Minor cracks were reported across Kingston and St. Andrew in driveways, car parks, and along paved surfaces at private residences. I mean, even my aunt's kitchen wall had a crack in it after the earthquake. At the Rockfort Mineral Bath, ground cracks were observed along the driveway, and there was an abnormally high water level at the bath following the earthquake. And interestingly, the paper notes that a similar phenomenon occurred at the bath during the 1907 Kingston earthquake. Ground cracks were also reported near Hunts Bay Police Station along the Portmore Causeway. And for viewers who may not remember it, the Portmore Causeway used to be the main road connecting Portmore to Kingston. Today, this corridor has largely been replaced by Highway 2000, specifically the Portmore leg of Highway 2000. Another interesting phenomenon discussed in the paper involved submarine landslides. So about 2 kilometers offshore, several kilometers of submarine cable were disrupted, suggesting that slope failure likely occurred on the seafloor. There was also a fish kill reported at the western end of the Kingston Harbor 4 days after the earthquake. In the absence of any other clear explanation, Ahmad suggested that this may have been related to sediment plumes generated by submarine landslides. When you look at these different geophysical and geotechnical aspects, from cracking to liquefaction to landslides on land and even submarine landslides, it's somewhat surprising that this earthquake isn't cited more often, at least to me anyway. Now, I fully understand that the island has experienced more destructive earthquakes, and those events, quite rightly, received the spotlight. But there are a few things worth noting. First, both those famous earthquakes happened a very long time ago. The 1907 Kingston earthquake occurred over a century ago, and the 1692 Port Royal earthquake happened more than 3 centuries ago. But an earthquake like 1993, even though it was smaller, provides a really important modern data point for structural geologists and even engineers. Yes, it was over 30 years ago, but the Kingston of 1993 looks much more similar to the Kingston we have today, as opposed to Kingston from 100 years ago or 300 years ago. And speaking of modern Kingston, who remembers the earthquake of October 30, 2023? That event had a very similar magnitude of about 5.4. In 1993, I experienced an earthquake as a child. In 2023, I experienced one as a professional geologist. From my perspective, one key difference was the location of the epicenter. The 2023 event occurred farther away from Kingston and was relatively shallow, about 10 kilometers deep. Because of that, the destructive energy was more localized and less likely to produce the kind of widespread effects like 1993 did. Another possibility, and this is just me thinking out loud, is that construction practices may have improved over the years, the past 30 years. I should say clearly that these are just hypotheses on my part. I don't have empirical data in front of me to confirm that. But my broader point is this. When we talk about earthquake history in Jamaica, we shouldn't limit the discussion to just 1692 and 1907. Moderate earthquakes like 1957, 1993, and even 2023 may be less destructive, but they provide valuable scientific insight and deserve to be a part of the conversation as well. So we've come to the end of this seismic story, a story that in many ways is still ongoing. After all, we never really know when the next significant earthquake will affect our island. What this reminds us of is the importance of staying prepared and staying informed. With all the development and construction happening in Jamaica today, this is something we always need to keep a close eye on. And as we've seen today, even moderate earthquakes can reveal a lot about the geology beneath our feet and the hazards we may face in the future. That's it from me for this seismic story, and I'll see you next time. Take care.